Jai Hind, my dear children. Welcome to another section of chemistry online class. I hope you are all staying safe and fine. Have you all watched previous video? In previous video, we have started the chapter chemical reactions and equations, and we have studied how to write the equation. Today also, we are continuing the same topic, writing equations and balancing equation. So let's move to our topic. Let us begin with the first example, which is a very simple one we have discussed on the previous class. Hydrogen react with oxygen to form H2O. This is the molecular formula of hydrogen, this is the molecular formula of oxygen, and this is the formula of H2O. Here, when you see this, you can see there are two hydrogen atoms on the reactant side and two hydrogen atoms on the product side. Here two oxygen atom on the reactant side, but only one oxygen atom on the product side. This means that this equation is not balanced one. This equation is not balanced one. A balanced equation is one in which the number of atoms on the reactant side and number of atoms on the product side should be equal. A chemical equation is based on law of conservation of mass. Law of conservation of mass states that mass can neither be created nor be destroyed during a chemical reaction. So this equation does not obey law of conservation of mass. We have to make this equation balanced. So how can we make an equation balanced? Let's see some steps to make the equation balanced. When we make an equation balanced, we can add suitable coefficient. We can multiply these reactants and product with suitable coefficients, but we should not change the molecular formula of the reactant or product. That means H2 is the molecular formula of hydrogen. We should not make any change in the molecular formula of this reactant. We should not change the molecular formula of O2, and we should not change the molecular formula of H2. Instead, we can multiply using suitable coefficient in front of the reactants and product. So let's see. We have to mark like this LHS and RHS. LHS is the reactant side, RHS is the product side. We can write the number of atoms on reactant and product side. Here on the reactant side, there are two hydrogen atoms. On the product side also, two hydrogen atoms. Here on the reactant side, there are two oxygen atoms. But on the product side, there is only one oxygen atom. That is, oxygen is not balanced here. So, how can we make these oxygen atoms balanced? Here, if you want to make this 1 into 2, we can multiply here using the coefficient 2. So, here 1 into 2, it becomes 2 oxygen atom. That is, we have to multiply the product side by 2. We have to multiply the product side by 2. Now we can see on the product side there are 4 hydrogen atoms. On the reactant side there are only 2 hydrogen atoms. So we have to multiply the hydrogen atoms on the reactant side by 2 to make it 4. It is a 2 has to be written here also. Now this equation becomes balanced. 4 hydrogen atom on reactant, 4 hydrogen atom on product. 2 hydrogen on reactant, 2 oxygen on reactant side, 2 oxygen on product side. Now this equation becomes a balanced equation which is obeying the law of conservation of mass.
Hydrogen reacts with oxygen to form water. And we saw the reason why this chemical equation is unbalanced. The number of oxygen atoms on the left is not equal to the number of oxygen atoms on the right. The important question is, can we balance this equation? The answer is yes. Let's go step by step and see how we can balance it. As the first step, it's always a good idea to draw boxes around each element or compound, like this. Why did we draw these boxes? It's because nothing inside the boxes can be changed or altered when we are balancing the equation. You'll understand better soon. Next, we form a table like we've already drawn here. This row in the table tells us that the number of atoms of oxygen on the reactant side is not equal to that on the product side. It's 2 on the left and 1 on the right. So let's try balancing the oxygen atoms first. As there's 1 oxygen atom on the right and 2 on the left, we multiply H2O with 2. What we have here is a partially balanced equation. The number of oxygen atoms on the right is 2 and that on the left is also 2. Also remember that you cannot alter the formulae of compounds or elements involved in the reaction, which means that to balance the oxygen atoms, we cannot change H2O and write it as H2O2. This would be incorrect. Let's go back to the partially balanced equation. The number of oxygen atoms on each side is balanced now. But what about hydrogen? When we multiplied this compound with 2, what happened? The number of oxygen atoms were equal on each side, but what about hydrogen atoms? The number of hydrogen atoms on the right became 4. And what's the number of hydrogen atoms on the left? It's 2. So how do you think we can balance the hydrogen atoms now? We can multiply the hydrogen on the left-hand side with 2 to get this. Is the equation balanced now? Absolutely. We can form the table and verify it. This is what you'll get. So we simply multiply the appropriate elements or compounds as necessary to balance each and every element. When all elements are balanced, we say that the chemical equation is balanced.
Second example given here is the formation of magnesium oxide by the reaction of magnesium and oxygen. So how will we write the equation? Magnesium plus oxygen gives magnesium oxide. This is the formula of magnesium oxide. Valency of magnesium is 2, valency of oxygen is also 2. Therefore formula becomes MgO. Here on the reactant side there is only one magnesium atom. So we have to write 1 on the LHS side. On the product side also 1. On the reactant side there are 2 oxygen atoms. So we can write 2 here. On the product side there is only 1 oxygen atom. So oxygen atoms are not balanced here. Here 2, here 1. So what we have to do? We can multiply here by 2. Therefore it becomes 2 oxygen. But what will happen here? If we multiply here by 2, here if we multiply by 2, this 2 become applicable both for magnesium and for oxygen. So we have to multiply the magnesium atoms also by 2 like this. So the number of magnesium atoms become 2, number of oxygen also become 2. But on the reactant side there is only one magnesium atom. So we have to multiply here also by 2. Thus it becomes 2. Now the equation becomes balanced. 2 magnesium plus 2 oxygen. Here also 2 magnesium, 2 oxygen atom. So now the equation is balanced. Another example is iron plus water gives Fe3O4 plus H2. So this is a symbol of iron, Fe. Here also this equation is not a balanced equation. Here on the reactant side, one iron atom, Fe atom. On the product side there are 3 Fe atoms. Hydrogen atoms, there are 2 hydrogen atoms on the reactant side and 2 hydrogen atoms on the product side. Now oxygen, here there is only one oxygen atom on the reactant side, but here there are 4 oxygen atoms. So iron is not balanced here, oxygen is also not balanced here. So let's multiply with suitable coefficients. Here on the RHS side there are 3 iron Fe atoms. LHS side there is only 1. So first we multiply here by 3, therefore it becomes 3 Fe atom. So put a 3 here. Okay, here also 3 Fe, here also 3 Fe. Now hydrogen, okay. Now oxygen. Here there are 4 oxygen atoms, here only 1 oxygen atom. Therefore we multiply here by 4. Thus it becomes 4. So we can put 4 here because the reactant side oxygen is multiplied by 4, therefore we put 4 here. Now the number of oxygen atoms become 4 on the reactant side and 4 on the product side also. But the number of hydrogen atoms become 2 into 4, 8. Here only 2. So here it becomes 2 into 4, 8. But here there is only 2. So how can we make this 8? By multiplying by 4, it becomes 8. So here on the product side, we put 4 on hydrogen. Now the equation is balanced. See here, 3 Fe atom, 3 Fe atom. 2 into 4, 8 hydrogen atom, 2 into 4, 8 hydrogen atom. 4 oxygen atom, 4 oxygen atom. Now this equation becomes a balanced equation. I hope today's topic is clear for you. You have to work with more examples. Some example questions are given as home assignment. Please do it and send it as early as possible. Thank you.